So, welcome everyone for today's water and wastewater treatment live session from NPTEL, and I am Saptoshi Bose, human research scholar from IIT Madras. So, as usual, we will try to solve various numerical questions as well as theoretical questions, and which will help you throughout your examination, maybe your post examination or other kind of examination like for the job or gate, something like that. So the first question is a theoretical one. What is the basic difference between anoxic and anaerobic condition in reference to phosphorus removal? So there are four options. You can use your chat section to write it or in message section. Multiple options are correct. So think carefully and write your answer. Already we have discussed similar question in the last week. So there is no electron acceptor present in the anoxic condition, or the free oxygen is the electron acceptor in anoxic conditions. There is no electron acceptor, free or bound oxygen present in the anaerobic conditions, and bound oxygen, suppose NO3 minus, is the electron acceptor in anoxic conditions. So this is a very easy question. So maybe one more minute, then we'll go for the solution. Yes. So the correct answer will be C and D, because here you can see that there is no electron acceptor, right? Free or bound oxygen, whatever it is, maybe free or bound oxygen present in anaerobic conditions. So in case of anaerobic conditions, there will be no electron acceptor, maybe free or bound oxygen. But in case of anoxic conditions, bound oxygens will be present as electron acceptor. So this is the main key difference, B, C and D. Right? The next question, you have to match two tables related to settling, discrete settling, populate, or compression at the end, hindered zone settling. Think carefully and write your answer. Again, very easy question, so all should participate and try their best. one more minute because this one is very easy one. Again, then we'll move to the next question. Is Abdul is saying anything? I can't hear. That's why I'm asking. Oh, there is some issue. I can't hear you properly. So the correct answer is C. Here you can see that the biscuit settling is happens when at the uppermost area of the clarifier where solid concentration is relatively low. So in that portion, all the particles at discrete concentration is very low, so they can separately come down. Then the flocculant settling, number two, it is in the area in the inlet area just below the uppermost region. Upper, this is the uppermost region. After that, there will be flocculant settling because the concentration is higher as compared to this portion. So there is chance of flocculation here. And then the compression settling, we can see what is compression settling related to. This at the end, like at the end when the pressure is getting increased, then the water is coming out from this zone at the bottom. So there we can see this compression settling, the height will reduce. So this is compression settling and then hindered zone settling. It is in between these two where they are settling as a zone. They are completely forming as a zone. Here it was flock length. Various flocks were forming, though they were individual. And in this case, after this portion, there is as a zone, it is coming down or it is getting settled. So that's why we are saying this compression settlement, right? And hindered settlement. Is a clear interface between settling solid and supernatant. So above this one is the supernatant, and there is this at this interface we can find this hindered zone settlement. Next is why is sludge loading rate limited to 5 kg per meter square per hour in secondary clarifier? Just think logically. You don't have to remember the number right now, but think logically what might be the reason. So that is the main point of this question. Use your chat section to write your answer. What is the reason behind this sludge loading rate to be limited to certain number in case of secondary clarifiers? Sorry, I can't hear anyone. Let me check once. There is some problem. hello, 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 hello. Can you write your answer? Am I audible to everyone, right? Because there is some issue with my.
Yes, yes,
Okay,
yes, audible.
okay. Thanks
Yes,
then.
audible.
Option B.
Oh, okay. Thank you, Ruchita. So we'll wait for a few more minutes, maybe one for other persons to answer. Ranjit, Saif, Abdul.
It is D.
Oh, thank you, Abdul. So you are saying it's D. Okay. Fine. So the right answer is B, not D. Because in case of if you are going for a higher sludge loading rate, what will happen at the bottom portion? Let me. What will happen? Suppose this is my secondary clarifier. Suppose this one is whatever is now going on. That is the sludge loading rate we are getting, and that's why there's much volume of the sludge I am getting. So you can think as a 3D picture or something like that. But what will happen if this surface loading rate is going to be increased? Then maybe this portion that much. And just for example, I'm taking this one. So it will create a septic condition at the bottom. So not enough oxygen will be there, can enter there at that depth at the end of this portion. There will be some septic condition and it will decompose the sludge. So the sludge will be not active first of all. So if you are thinking about the activated sludge, it will be not active. There the bacteria cell will die and there will be some decomposition. So the next question is which of the followings is or are attached growth processes? I discussed this type of questions in the last session also. So it is very easy for everyone.
बेटा बेटा गिर जाओगे
Option D, E and D and E. Option D
Okay,
and E.
okay. Thank you, Ruchita.
जाने मार सब यही खाना है
Uh, I request like other persons to you can switch off your mic, you can mute your mic, and you can use the e-message section or chat section to type because like some outside noise is coming, right? Background noise are coming. That's why I'm saying you can open and you can say no problem from my side. But if you are in a noisy place, you can just write your answer. Okay, so you said like with the fine. So the correct answer is, it just one more, that B, C, D, E, and F. So I am getting, like, for B, this Stiglitz filter. I hope all of you are aware about this Stiglitz filter. Then this MBR. Here also we are using some kind of membrane for this attached growth development of the bacterial cell, and we are getting treated water. Then moving bread, biofilm reactor. I cannot show you the picture, I don't have right now. Then rotating biological reactor, but that I already explained how it works. Like, this kind of water is coming from this way, it's going from this way, and these are the discs or the rotating conductor which are rotating at a certain speed, certain velocity. It is rotating like that. So it is also kind of attached growth system. And then biotire. Biotire is nothing but the some advanced kind of tickling filter, you can say. So the next question, again theoretical question. Why do we need higher concentration of chlorine and contact time for microbes having relatively higher retention time? This one is a conceptual question. If you have clear understanding, you can correctly say what is the answer.
Sir, answer B, formation of slim layer around the cell wall.
Oh, thank you, Ranjit. Yes, you were saying that formation of stem. Anyone else want to answer? Okay, I got another answer from Amol. He's saying it's B, right? So B is the correct answer. Formation of slime layer around the cell wall of the older microbes can take can make them relatively more resistant, right, for the oxidation. That's why we need a higher contact time and higher concentration of chlorine, right? So the next question is, which of the following compounds will remove E. coli most efficiently present in the wastewater for the contact time of 10 minutes and 4 degrees centigrade?
Sir, maybe answer C, both OCI minus and NH2Cl.
Thank you, Ranjit, for your answer. Quick answer. We see anyone else want to. I got another answer from Amol. D, right?
Option A.
Okay, thank you,
Option,
Ruchita.
option A.
Thank you, Ruchita. You are saying option A. Anyone else or you go for those? So the correct answer is D, HOCl, because this is the most effective one among OCl minus or amine chlorine. Because first of all, HOCl and OCl minus hypochlorous acid and hypochlorite ion, these are called is free chlorine. So this is not that much effective, first of all. And if you compare between these two, then HOCl is the most effective one. So irrespective of the temperature or you can say the time, this one is the most effective. Another conceptual question, or you may say theoretical question. An industry is trying to disinfect water contaminated with virus with chlorine gas. Destruction of the cell wall of the viruses need a strong oxidizing agent, preferably HSA. And pKa value is given at 7.5. At what pH should the industry maintain to achieve the effective disinfection? One hint is given as assume OCl minus will not be effective for the disinfection of the viruses. Very easy but tricky question. Answer is already given here.
I think answer is B, maybe.
Thank you, sir. You are saying that B. So I'll wait for few more students to answer.
Yes, sir. Sir, I guess answer A, 5.2.
Ranjit, okay, thank you. Thank you so much. Anyone else?
Answer is A, 5.2.
Thank you, Abdul. 5.2. Yes, correct. Like most of you are saying that 5.2 because if you check with the other options, then these values are beyond the 7.5 pK value, right? So if the pH level is at 7.5, then it is the equilibrium condition when there is as much as HOCl and that amount of OCl minus is present. So if you are crossing this limit, then mostly the major percentage is OCl minus, right? We will not get that much of HOCl. And one thing is mentioned here that OCl minus is not that much effective. So at the end, I have only one option left, that is 5.2. The next one is the select the correct statement regarding ozone disinfection.
Sir, answer maybe E, F, B, and C. B, C, D, E.
Thank you, Ranjit.
B, yeah, B and D.
Thank you, Ruchita. It will take.
Answer B and D. B and D. More
uh,
costly than chlorine disinfection and effective against taste and odor. B and D.
right, right. So the answer is more costlier than chlorine disinfection. This is the correct one, and also effective against taste and odor. It will not uh, create other odor or taste. In place of chlorination, we can find that taste and odor is there, right? Whichever water we get from our municipality in our country, we get some kind of taste and odor. So, and also, sorry, I missed one, right? Yes, yes, I missed another thing. It requires relatively shorter contact time because for chlorination it will take a longer time to destroy the cell wall, but in case of ozonation, the oxidation potential is higher, so it will oxidize in a relatively shorter contact time. So the rate of oxidation is higher in case of ozonation. That is the reason.
What is meant by option C, sir? Can you explain, please?
Does not form harmful byproducts even if bromide is present. So in case of chlorination, what will happen that it can form for suppose for a case of ammonia also it can form certain kind of chloroamide, right? So you heard about this chloroamide thing like NCl3 and NHCl2, something like that. So in case of bromide also, it may form some byproducts if you use chlorination. But in case of ozone, if you use that, it will not form any byproduct. No other chemical will be formed because in, in the water there might be various kinds of ammonia or bromide. This ammonia may not be harmful, but if it is chloroamine or it is like chlorobromide, it is much harmful or carcinogenic. It can cause cancer.
Okay, thank you.
Ah, thank you. Next one related to phosphorus removal.
Sir, answer maybe D, option D.
Yes, thank you, Ranjit. You are saying D, biological phosphorus.
Option B and C.
Okay, thank you, Rishita. B and C, phosphorus. So the correct option is anyone is writing. Yes, the correct option is B and D. The phosphorus can be removed from the wastewater by ferric chloride. Any trivalent ion will form a precipitate with phosphorus. It will go down, settle, so we can remove that, and also the biological phosphorus is removed by promoting phosphorus accumulating organisms by providing the alternative anaerobic and aerobic conditions for the treatment. So the next one, this one is a numerical question. Hypochlorite acid. Hypochlorous acid is added for disinfection and deprotonates as shown in below. I think all of you are aware about this. K value is given. The sum of HOCl and OCl minus is known as fluorine, right? And that 80% fraction of the HOCl in the fluorine, that is given. How much HOCl is present? The value of pH. What is the pH of the solution? You have to calculate. So quickly calculate this. You can refer to the formula. If you need your help, you can refer to your notes. You can refer to your book, but try to solve it as quickly as possible. Sorry. Maybe 2 more minutes, then we'll go for the solution. Okay, we will go for the solution. Please note it down carefully because we may solve similar questions later in today's section. So that time you should solve by yourself. Basically, we will use Heisenberg equation here. So the pKa value we need to calculate. You know what is the pKa value? This is the negative logarithm of Ka value. K is the acid dissociation constant, which is given at 2.7 multiplied by 10 to the power minus 8. So you can write it as minus logarithm 10 base of 2.7 into 10 to the power minus 8, and we are getting a 7.56. Now the total free chlorine equals to HOCl plus OCl minus, and HOCl is given as 0.8 of the free chlorine, that is 80% of the free chlorine, right? 80% fraction of the HOCl in the free chlorine. So the pH equals to, this is the Henderson-Hasselbalch equation. All of you are aware about this one. pH equals to pKa plus log of OCl minus divided by HOCl. These are the two components I'm getting inside this free chlorine, or better to say, yes, in that way we can say this is the total concentration. Now this one is fine. So pH equals to 7.56, that is the pKa I calculated here, plus log of 0.2, this is the 20% of the free chlorine. If HOCl is 80% present, then this will be the remaining, that is 0.2 Fc, and this 0.8 Fc, it will cancel out Fc, so not required here. If you calculate, you will get pH as 6.95. Hope this one is clear for everyone. So we'll move to the next one. 40 ml wastewater plant has a surface overflow rate as 10 meter cube per meter square per day. Recirculation ratio is given as 0.5. MLSS concentration is 2500 mg per liter. You need to calculate the solids loading rate in kg per meter square per hour. Please calculate it quickly and write your answer. 3 to 4 minutes I will give. This one is very easy one. I already discussed this type of question in the last session. So all should attend this. So I didn't get any answer. So we will move for the solution. So the solution is very easy for this one. It was given as
I
surface.
think
Yes, Ruchita, you want to say something?
I have calculated 1.044 something.
Okay, no problem. You
Yeah.
can check your calculation also. You can check my calculation. Might be I might be wrong. So but the concept is something like that. The ASO over or the surface overflow rate was given as 10 meter cube per meter square per day, and RR, which is recirculation ratio, is given as 0.5, MLSS concentration 2500. So SOR, that is nothing but Q, that is a flow rate divided by area, surface area. I'm getting whatever the surface area of this tank. And here it was written as 10, and this one is 40 mld, right? So convert the unit carefully. That's what I always say, that you have to be careful while converting the units. So from here I am getting a surface area as 4000 meters square. And this is a sludge loading rate, which is nothing but Q plus Q bar, whatever is coming, right? And we are also multiplying with X and divide by a surface area. So whatever load of the MLSS is coming inside this, what to say, suppose this is my tank or activator slash reactor. This is my surface area, or the 3D picture. Suppose this is my surface area, right? So whatever flow is coming, how much is coming? Q plus QR, whatever is recycled thing is coming out from here. This is the QR going out. This way QR is coming, and the RR was given as how much? 0.5, right? That is the half. So if Q is 40, then this will be 20, right? And then we are getting also how much this 2500. So just work with your units, be careful with the units, and then divide by 4000, right? And I am also converting it into per hour. This is my the unit should be in hour. It was mentioned kg per meter square per hour. So always be careful with all the units. Might be something it was in day, and it's the answer should be a per hour. So always be careful. That's why we are doing this multiplied with 24 at the bottom, and I'm getting as 1.56. So the next question is, what is the correct sequence of the formation of following compounds during chlorination of the water, in which ammonia is present? If ammonia is present in the water, if you add chlorine or any form of chlorine for the chlorination purpose, so what is the sequence I'm getting the compounds?
Sir, option 231 D.
2, 3, 1, you're saying B. Anyone else want to answer?
Option 213 D. Option D.
You are saying option D.
No, option. Just wait. Just wait. Option B.
Thank you, Ruchita. So you are saying option B. Wait,
Answer C. Answer
yeah,
C, sir.
Abdul, thank you. You are saying C. So I am getting B
Answer
and
C.
okay, fine. So the correct answer is this one will be the first one. Two, when the chlorine is coming towards the ammonia, it is making a compound. I am getting an H2Cl first. Then one hydrogen is getting replaced by another chlorine. Then I am getting this one, two, three. Then this hydrogen is again replaced by another chlorine. I am getting NCO3. So the sequence is 2, 3, and 1. Option B. Next one, in a trickling filter system, the biomass at the interface of biofilm and the media surface undergoes what?
Option D.
And you are saying option D, right? Maybe one more minute, then we'll go for the solution.
Answer D, sir.
Thank you, Ranjit. You are saying but the correct answer is option D, because what I am saying, this suppose this is the rock for the trickling filter or any plastic material, boulder material. So above that, I am getting this biofilm growth, bacterial biofilm growth. So then this interface, which is the interface of this biofilm and the media surface, this is a media surface. It might be any stone or any polymeric boulder or the plastic boulder. This is my media, and this is the biofilm, right? So this surface, this portion, which is the interface, this portion is our concern portion. What will happen? This biofilm will grow day by day, and it will be very difficult for this portion, whatever bacteria is present here or microbes is present here, to get proper oxygen. So oxygen will not enter properly to that depth. So it will be anaerobic condition first of all. Then it will also not get enough food or enough organic matter because of this depth only. So it is very difficult to penetrate up to this depth. So they will also starve, and then they will go for endogenous respiration. So in that case, what they will do, they will use their body material as a fuel. So they will self decompose their body, or you can say their structure. So that's why we are getting this endogenous respiration, because they are not getting enough food. So they are decomposing their own self or own body. And at the end, yes, I forgot this. At the end, what will happen that they will be very weak and it will slug off from the media. So that's why we are getting this slug off from the media, and media is clean for another set of biofilm growth. At the bottom of this tickling filter, I am getting this sludge, so I can take them out. So that is the main concept. That is infection efficiency of hypochlorous acid in the treatment is dependent or not dependent on pH value. Increase with the increase in the pH value remains constant or decrease.
Option D answer. Option D.
Thank you, sir. You are saying this option D. Okay, let's see what other students are saying. Agree with this or different opinion?
Option D.
Thank you. You are saying option D. Right. Option D is the correct answer
Yes.
because with the increase of pH value, I am getting more OCl minus. So it is the graph is something like that. So suppose this is my graph, this is my pH. If pH is increasing, then if this is HOCl, HOCl is go down. This was suppose 100% and this is the 0%. So as we increase the pH, it is going down. You should solve this question. I already discussed this kind of question in this session. An acid dissociation uh, is given. H is getting dissociated at H plus and A minus. pK value is given. pH of the solution after addition of H is given 4.2. The concentration of ion, that is A minus, at the equilibrium is given as 10 to the power minus 2.6 mole. And if X is the total concentration of HA in the solution at equilibrium, then what is X multiplied by 1000? The same concept. Please try to calculate this. I may give 3 to 4 minutes to calculate. One more minute, then we will come for the solution. So the solution is something like that. The correct answer is 1.148. Concentration of ion AF was given as 10 to the power minus 2.6 mole. pH was given as 4.2 and pK value was given as 3.86. Here also we will use this Henderson-Hexelbach equation, and you know what is it? This pH equals to pK plus log of A minus concentration divided by H, right? So the pH I am writing as 4.2. It was given pK value was 3.86. Log of 10 to the power the concentration of A minus N is given as 10 to the power minus 2.6. And you have to calculate the H concentration. I am getting it as 2.148 into 10 to the power minus 3 molar, and if you just multiply it with 1000, so I am getting 1.148. Oh, I missed the next question. So question is not available, whatever it is. So somehow I missed the question. It was regarding the Chick's law. The solution is only here. I will upload the corrected PDF in the Google Drive. So it is basically about the Chick's law. The Chick's law is something like that: NT divided by N naught. NT is the number of bacterial cell, you can say, or the microorganisms at time t. This is the number of bacterial cell or microorganism at time 0, or the initial time. We are using chlorination. We are also uh, assuming as the first order reaction. So in that case, it is e to the power minus kT. Right, all of you are aware of this first order reaction. And this is T is the time, contact time. T is the rate at which this number is getting down, or bacterial cells are dying, the killing rate. So here it was at time T, it was for 7 minutes. If the contact time is 7 minutes, then first you have to find out the K value, that is 0.46. How I got this K value? Because it was given as after 7 minutes, 96% of the bacterial cell were removed, right? So initially it was 100%, and after T time, that is T time means the 7 minutes, now 96% removed. So how many are there? Only 4 are there, right? 100 minus 96, 4 by 100, and that is equals to e to the power minus k into 7, right? So if from here, this situation, you can find out what is the k using this ln. That is, I'm getting as 0.46 per minute. Now 99% is the efficiency required. So I am writing again NT by N naught, that is 1 minus 99 divided by 100, and that is equals to e to the power minus 0.46 into t, right? So now we have to calculate t. Again, ln use ln log natural logarithm, and you can calculate t as 10 minutes. So if I want 99% removal, I need the contact time as around 10 minutes. If I need 96% removal, I'm getting that, I'm reaching that, achieving that around contact time 7 minutes. That is the concept behind this question. So thank you for joining today's session. I hope you learned and enjoyed this session. So we'll meet in the next session on next
Thank you, sir.
Tuesday. Thank you.
Hello, sir. Hello, sir. What is the question of this solution? You are using. What is the question of last question answer?
Yes, yes. Actually, I missed the time preparing the slide for the last question. So
Yeah,
I'll
I
upload the
did not
question.
see that.
You
Okay,
can
okay.
find it in the Google Drive. I just sent the concept behind this kind of questions related to James law. So I will
Okay,
upload the
okay.
correct. Thank you.
Okay, thank you, sir.